Hello everyone, and welcome to another video in this channel. In this video, we are giving a question from Harvard University entrance examination. The question is 7 plus 1 over x all raised to power 4 minus 5 plus 1 over x all raised to power 4 is equal to 240. The condition is that x is a member of the set of real numbers. We are required to find the value of x. What many people will do to solve this problem is to first of all expand the brackets. This is raised to power 4, and expanding the two brackets will be cumbersome. Let's remember that this is a question inside an examination and we are given a particular amount of time. So we need to use the time judiciously. Therefore, expanding the bracket will not only be time consuming but will be cumbersome and even lengthy. So what are we to do to solve this problem? We need to make a substitution. I'm going to let y equals to 5 plus 1 over x. If that's the case, if I add 2 to y, I have 7 plus 1 over x. Therefore, I'm going to put y plus 2 for this term in the bracket, and then y for 5 plus 1 over x in this bracket. So it becomes y plus 2 all raised to power 4 minus y raised to power 4 is equal to 240. Now I can rewrite this into y plus 2 raised to power 2 all raised to power 2 again, then minus y raised to power 2 raised to power 2 is equal to 240. So basically what I have is difference of two squares. So if I have a raised to power 2 minus b raised to power 2, it will expand into a minus b times a plus b. So let us apply this expansion of difference of two squares here, where a is y plus 2 raised to power 2 and b is y raised to power 2. So I have y plus 2 raised to power 2 in the first bracket minus y raised to power 2. Then another bracket I have y plus 2 raised to power 2 plus y raised to power 2 is equal to 240. Now, let us expand y plus 2 all raised to power 2. It will give us y squared plus 4y plus 4, because y times y is y squared and y times 2 is 2y. 2 times y, another 2y. When we add them together, we'll have this. Then 2 times 2 is 4. So I'll put this in place of this where I have them in the bracket. So it becomes y squared plus 4y plus 4 minus y squared in a bracket. Then another bracket I have y squared plus 4y plus 4 plus y squared, close the bracket, equals to 240. This and this will cancel out. Then I will need to add these two together. That becomes 4y plus 4 in a bracket. Then in another bracket I have 2y squared plus 4y plus 4 is equal to 240. Now 4 is common in this first bracket. If I factorize it out, I have y plus 1 remaining, then 2y squared plus 4y plus 4 equals to 240. So I need to divide both sides by that 4 that I factorized out. This and this will cancel out, giving us y plus 1, then 2y squared plus 4y plus 4 equals to 4 here 1, 4 in 240 is 60. Again, 2 is common in the second bracket. If I factorize that 2 out, I have y plus 1 in the first bracket, then y squared plus 2y plus 2 in second bracket equals to 60. If I divide both sides by 2, these 2 will cancel out, and 2 here 1, here is 30. Therefore, y plus 1 in the bracket, y squared plus 2y plus 2 in another bracket is equal to 30. I now need to open this bracket. So y times y is y cubed, y times 2y is 2y squared, y times 2 is 2y. 1 times y squared is y squared, 1 times 2y is 2y, 1 times 2 is 2 is equal to 30. So I'll add these two together and then add these two together. So it becomes y cubed plus this and this is 3y squared. This and this will give us 4y. Then plus 2 is equal to 30. Now Let me bring this one here. So it becomes y cubed plus 3y squared plus 4y minus 28 is equal to 0. So I have a cubic equation. Now, if I substitute 1 for y here, I will not get 0 in the right hand side. Also, if I substitute minus 1 for y here, I'm not going to get 0. But if I let y equals to 2, I have 2 raised to power 3 plus 3 times 2 raised to power 2 plus 4 times 2 minus 28 is equal to 0. 2 raised to power 3 is 8. 2 raised to power 2 is 4. 4 times 3 is 12. Then 4 times 2 is 8 minus 28 is equal to 0. When we add these two together, we'll have 28 minus 28 is equal to 0. It simply implies that y minus 2 is a factor of this polynomial. And if that's the case, it is divisible by 2. Now, I'm going to divide the coefficient of this polynomial by 2 by a method called synthetic division. So what I will do is this. I'm going to draw a line and then write the coefficient. Here is 1, and then 3, we have 4, then minus 28. I'm going to divide them by these 2. So let me bring down this one. 2 times 1 is 2. I write it here. 3 plus 2 is 5. Then 2 times 5 is 10. 4 plus 10 is 14. And then 2 times 14 is 28. And minus 28 plus 28 will give us 0. So these are now the coefficients of another polynomial equation, which is quadratic. So let's remember that if we divide this polynomial by its factor, we are going to get a polynomial of a lesser degree, which is this now. Then these are the coefficients which we got from here. So we're going to solve this one using the formula method, because this cannot be factorized. Then y equals to minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is equal to 1, b is equal to 5, and c is equal to 14. So y equals to minus b is 5 plus or minus the square root of b squared, that is 5 squared, is 25, minus 4 times 1 times 14 all over 2 times 1 is 2. So y equals to minus 5 plus or minus the square root of 25 minus 4 times 4 is 16. 4 times 1 is 4 plus 1, 56 here. So we have this. And we have a complex number. So we have minus 5 plus or minus the square root of minus 31 all over 2, which will give us minus 5 plus or minus I root 31 all over 2. We are going to reject this because the condition is that x is a member of the set of real numbers. So this is not a real number, but instead it's a complex number. The only real number is that y equals to 2. So let's remember that y is equal to 5 plus 1 over x. Substituting 2 here, we have 2 is equal to 5 plus 1 over x. Then minus 3 is equal to 1 over x when we move this 5 to this side. And then x equals to minus 1 over 3.